Hello everyone, in this video we will see how we can generate and visualize unit step signal in MATLAB. So unit step signal is a kind of signal where once the signal is on, the signal is available throughout the time. For say example, if you consider, let's say the bulb is off initially, and the moment I switch on, the bulb is going to be on for a infinite period of time, right? So this kind of signal is called as unit step signal. So as you see here, the unit step signal can be mathematically represented in both continuous time and discrete time. So in a continuous time, the unit step signal can be mathematically represented whenever time t greater than or equal to 0, the signal is 1, and all other cases the signal is 0. Similarly, in a discrete time, the signal is equal to 1 when n greater than or equal to 0, and all other time the signal is 0. Right, now let's see how we can generate and visualize the signal in MATLAB. So as you have seen before, first we should create x-axis data, right, both for continuous and discrete time. Okay, so I just name this file as, let's say, step signal. So first I create time axis data, that is x-axis data for a continuous time. So as we did before, let's keep that as -10, 0.001, 10. This is for a continuous time. Then for a discrete time, I just keep that variable name as n equal to, again, -10, 0, that is 1, right, 1, then 10. Okay, so then I just name that figure as step signal. Right, done. Okay, now I wish to again plot step signal in continuous time and discrete time in a single window. So I'll go with the command called subplot for that. Right, so let's keep number of rows 2, number of columns 1. I wish to keep first step signal in a continuous time in the position 1. Right, so followed by I need to create a amplitude. So as we know that the continuous time, the step signal is equal to 1 when time t greater than or equal to 0, and whenever time less than 0, the signal has to be 0. Right, so let's fix this. Right, I take that variable name as, let's say, y1. So now again I am going with the comparison operation. Whenever time t greater than or equal to 0, I am going to fix y1 as 1, and all other time the y1 as 0. So this is a comparison operator. It check for all the time step, and for all the t, that is whenever the t greater than or equal to 0, it is going to make y1 as 1, all other case y1 as 0. So now I created a amplitude. Now I go for plotting the impulse signal by using a command called plot. First call the x-axis variable t and followed by y-axis variable y1. Okay, then we just label the x-axis data and also title. So I just copy this one from the previous case and paste it here, and x label same time, y label amplitude, and title let's change to step signal in a CT. Right, okay, now same way we should do it for discrete time. So for a discrete time we have to check for n. Right, so first let's keep the subplot, that is plot position. I'm going to keep plot in the second portion, so it has to be 2 comma 1 comma 2. Right, now I have to make a amplitude. So in a discrete time, the step signal is equal to 1 whenever n greater than or equal to 0. So I go with the same comparison operation. So I just declare the amplitude of step signal in a continuous time as in a discrete time as y2. So y2 equal to, and I'm going to check it, right, whenever n greater than or equal to 0, then y2 is 1, and all of the time the y2 is 0. So as I said, this will check for each of the n, and whenever the n greater than or equal to 0, the condition is true, then it automatically assign y2 as 1, and all other cases it keep y2 as 0, because in all other cases this is a false condition, so false condition automatically assumed as 0, right? Okay, now we made an amplitude, so I go for making a plot. For a discrete plot we will be using a command called stem. So stem, our x-axis n, y-axis y2, right? Then I just label the variables, copy, paste, change this y label as samples, and this is step signal in discrete time. That's it. Save and run. Yeah, you'll be getting a exact step signal, right? You see the first one is about continuous time. You see whenever t greater than or equal to 0, the step signal is 1, and all of the time the step signal is 0. Similarly in a discrete, you see whenever n greater than or equal to 0, the step signal is always 1, and all of the time the step signal is 0. Actually in a label we made a mistake. So actually x label is about sample and y label is about amplitude, right? Just run this again. Yeah, so x label is sample and y label is amplitude, right? I hope you understood how we can build step signal in MATLAB. Thank you.